presenting GoalNet. Apologies, the title in the program is not correct. The GoalNet part is correct. It's probably a mistake by me. But we have Jacky Jiang. He's a student at Rice University pursuing a BS in computer science and a BA in sports analytics. Very much interested in pursuing a PhD in a research route type of career. So let's welcome Jacky. Presentation.
Good afternoon, everyone. My name is Jacky. I'm a senior student at Rice University, majoring in computer science and sports analytics. Today is my great honor to introduce my research project, GoalNet, that is evaluating the underestimate hidden pivotal players, a GNN-based sports soccer player evaluation system. So before I formally start my presentation, I have a question for you. So who should actually win the Ballon d'Or? Vinicius or Rodri? Yeah, most people believe Rodri. But some people argue that Vinicius has a better stats. So according to the transfer market, Vinicius has 24 goals and 11 assists in the past season, while Rodri only have 9 goals and 14 assists. This is unfair comparison, right? Rodri plays as a defensive midfielder, while Rodri plays as a forward. Then how should we compare them? Who should win the title? How about using some traditional soccer analytics evaluation matrix for them? For example, VAPE. VAPE is a model that evaluates players and gives players credit based on each action happen on the pitch and assign these credits to the direct participants to all of these events. So let's look at a VAPE rating of them. So according to VAPE value, Vinicius is getting 22 and Rodri is getting around 16 and 8. Vinicius should win again, right? But why not? Let's keep this question in our mind and move forward. The second question I have for you is, do you know which player are the attacking core or the center player in each team's attack in the 15 to 16 EPL season? For some famous team, you definitely know, for example, Arsenal, probably Aaron Ramsey. But what about some less famous team? For example, Swansea City, for example, Leicester City. If they don't win a title last season, probably won't know, right? Let's use VAPE again to find a top player for each team. So this is the top player for each team. You can see some very famous names here, like Sanchez, Joshua King, William from Chelsea, Firmino from Liverpool, and Lukaku from Everton. But are these players we are actually looking for? We are looking for attacking core, right? I don't think so. If you observe closely, you can see that actually 17 of them are actually forwards, 2 attacking midfielders, and all these players are actually top 3 scorer. They are top 3 finisher in their own team. They are not a center player. They are the best finisher. That's not what we want. So in this research project, we want to find those core players, those attacking core in soccer. So traditional player evaluation system, for example, VAPE I just mentioned, they prioritize player direct involvement in the action, in the scoring process. If you do not have the assist, you don't have the score, you miss the credit at all. They don't have the context for that. They just ignore those earlier people involved in the attack flow, which is make the model evaluation not correct. So we define the attacking core and the center player as those frequently and effectively involved in the attack flow. So how can we find and capture the hidden contribution of those players, those attacking core and those center forward? So in this project, our data set is 15 to 16 EPL season. We have 2 kinds of data, the event data from StatsBoom and also the player-specific data from SofaScore. And we define a responsive variable as the expected threat changes. So expected threat is a concept brought by Karen Tsai a few years ago. It is developed to evaluate the likelihood that the action on the field will turn out to be a goal by evaluating the threat level on different zones on the pitch. So let's review our methodology. So first, for each event of the whole season, we will using the sliding window to create a graph representation. Then we put all of these graph representation into our graph neural network. After a fully connected layer, we have the the expected XT changes. And we train the model to optimize this model, to optimize the MSE of the XT changes. Let's break it down. So let's first talk about the graph construction. Like I said, for each event in the data set, we're using a sliding window to capture not only the current event, but also the previous k-1 events. So in each graph, we actually have k events. So by doing this, we actually keep the context of this action on the field. So for example, let's say we set k equals 3. That means each graph not only contains the information about the current action, current event, but also previous 2 events. So for all of the participants in these 3 events, we create a node for them. And for each node, that is for each player that involves in the past 3 events, we have these features. For example, goals, successful dribbles, tackles, accurate passes percentage, and all of these come from SOFA score I just provide. And for example, if in these 3 players, we have player A and player B, and player A pass to the player B. Then we have a directional edge from player A to player B. Then we create an edge based on that, based on interaction on these past K events. For each edge, for each interaction, we have player ID, timestamp, team ID, start and end location, type ID, which including pass, shoot, dribble, clearance, tackle, and lot, and also result ID, that is successful, unsuccessful, body part ID, action ID. So after creating a whole data set of the graph, we then pass the data set into the graph neural network. So after 2 layers of convolution layers, we have the node embeddings. And after the node embeddings, we use the global pooling to get a single embeddings for the whole graph. But after the fully connected layer, we will get a single expected stratum changes value for the predicted value for the whole model. And in this case, in this model, we are optimizing the MSE, that is a mean square error between the expected XT and the ground truth XT. After we have the fully trained model, we can put all the graph back again into the model. And this time, after 2 layers of convolution layers, we have the node embeddings. But instead of using the global pooling to generate the graph level XT changes, we have the node level XT changes, and we assign these node level XT changes back to this player as their credits. So after that, we will have a complete ranking for all players in the league in last season. So as I mentioned, we are optimizing on the mean square error. The other evaluation matrix we are using is the mean absolute error. So when we choose k equals 5, which is the optimal value we have, that is 5 events in each graph, we have MSE equals to 0.125 and MAE as 0.013. That is pretty good value compared to our huge data set. We also do some experiments to consider how many events we should include in each graph. That is basically the sliding window size. We try k equals 3, basically 3 events in a single graph. We also try k equals 5, k equals 7, k equals 9, and we find out that k equals 5 gets the optimal performance. So we choose 5 events in a single graph. So let's get back to our motivation. So do you know which player are the attacking core or the center player in each team attacking 2015 to 16 season? I think after having the GoalNet rating, we should have the answer for that. So this is the top player for each team. So we can see some like Aaron Ramsey, I mentioned, like Nemanja Matic from Chelsea, Gareth Barry, Drinkwater from Leicester City, Daley Blind. And among all of these players, we recognize there's only 1 player that plays as a forward. 12 players play as the midfielders, and defenders, there are 7 of them, which is much more reasonable compared to the original result from the VAPE model result, right? Because all the attack happening on the pitch starts, like most of them starts from our own half of the pitch. We start from the tackle, start for getting the ball position, and then we organizing, passing the ball forward, push the ball forward, finish the attack by doing shoot or dribble. So this result is a much better result from the previous result using a wave model. And let's see another result we got. That is the overall top 20 players with GoalNet ratings. The top one is Aaron Ramsey from Arsenal. You can see a lot of interesting names here, like Toby, like John Stones, like Ozil, Kyle Walker, Memphis. They're all different kinds of players. They play different positions. Why is that? If you take a closer look, Aaron Ramsey plays a B2B box player midfielders for Arsenal. They finished with the second place in the league last season. So it's normal for him to push the ball for his own half to the opponent's half. For Toby and John Stones, they are those center back that are famous for pushing the ball forward, using a long pass to organize the attack from their own box. And Ozil, classic playmaker, always definitely one of them. And Kyle Walker, he's a right back, but even though he's a right back, he's always want to go to the midfield line and play as a defensive midfielder. If you're familiar, he playing style in the city. And Memphis Depay, he also go back for the attacking midfielders and start getting a ball from there. So by this result, our model is a way better tools to evaluate players' contribution to the overall attack flow, rather than a wave model or other traditional model. So the application for our project is wide. Because, for example, player performance analysis for coaches and analysts. So, for example, coach design a tactic, and some players should have more tasks to organize our attack, but his GoalNet rating is relatively low. What is going on? We need to find it out. The second is basically scouting and recruiting from teams. People always want to find those master midfielders, for example, Luka Modric, Toni Kroos, and some players like that. But how can you find that? GoalNet should be a good indicator for that. The third is the tactical adjustment and game planning. For example, the best way to do the defense is always start from the opponent's half, from their own half of box. If we find these core players, we find this attacking center, we can ask our forward, our midfielders to put more constraint on these core players from the opponent team, and so that player cannot comfortably pass to other player on the finisher that finish or push or doing other tasks in attack. So we do have some limitation about future work. So one limitation is the data quality and availability, because we are open source data competition. All data are open source. I believe if we introduce more data from such a charge API, we can definitely improve our model accuracy, because current model data set has some limitation. They don't include every single event type happening on pitch. The second is the complexity and computational cost. It's a graph neural network, so it takes about 20 hours to finish 20 epochs, but that's normal for such a machine learning task. The third is the generalization across leagues. For example, some leagues like Series A or German series, they don't pay much attention to ground pass. Will that interfere the performance of model? Not sure. The fourth is the lack of real-time capabilities. So if we have a real-time capability, we can definitely let a coach and let a analyst to provide the new tactic for the second half, let's say, or after the substitution, make a substitution or make the decision on the pitch. So in the future, the first thing I would probably try is going to incorporate a real-time tracking data. So our plan is to have a pre-trained model across the leagues. And then after the first 10 minutes of a new game, we put these 10 minutes of game data as a fine-tuned data. And after that, we have fine-tuned model, and we can do a real-time application. The second is to expand the model to different leagues and competition. We'll probably introduce different stats from different leagues to see how we can do the cross-league. The third is the node and edge features and a graph feature experiment. So like I introduced, our graph include node and edges, and they have different features. But what if we introduce more features to them? For example, like the interaction angle, like the cosine of the interaction angle. What if we add that? Will that improve our model performance and something like that? So in conclusion, our model has a GN base that captures hidden players' contribution and focusing on attack initiator, playmakers, and those attacking centers. We overcome the limitation of traditional models by identifying the supporting roles that impact the team dynamics. We also deliver the actionable insights for coaches, analysts to make their decision. Then we also have the highlighted value of data-driven matrix in soccer that we can use to make a larger scale decision and next move for the overall club development. So let's back to the motivation. What about using our GoalNet rating for these two players? As you can see, Vinicius is getting 12.5, while Rodri is getting 15.6. You can definitely know that both players are very great. They beat every single player from the 15 to 16 season, every single player of them. But Rodri is definitely the better one because he's a defensive player, and that he won a Ballon d'Or. And that concludes my presentation. I would like to open to questions.
And we're gonna take a short break. You can scan that QR code. Thank that student speakers for their awesome talks. Round of applause. I'm not gonna say please clap, but scan those QR codes. Vote on those two presentations. Your vote will contribute to determining who is the winner of the Methods Student Track prize.